Yes, welcome to a quick way of creating structural design. We're going to use a simple table frame to create a structural design using square tubes. Show you the quickest way of creating this one, combining 2D sketch and 3D sketch. Okay. Once you open your SolidWorks, I'm using SolidWorks, by the way, that is the software I'm using for design. Okay, so quick way, just file, new part, to file, new part or shortcut, click Control N, and the shortcut. So SolidWorks has this, be able to do part modeling, that is 2D and 3D, able to do that is 3D modeling. You create 2D sketches, then you convert to 3D sketch, then 3D models or features. Then you're able to do assembly from part modeling. You're able to create a 2D drawing from either part or assembly. But now we're doing part modeling. Then click on top plane sketch. We want to do a faster way of creating our part here. So let's put dimensions very quick. Smart dimension. So here we have put 1200. That is in millimeters, so it's in millimeters by 600. You can put a simple support here. Simple support is okay. You can exit this. That's 2D sketch. Then you go to 3D sketch. Say you're combining, so come to sketch again. First of all, once you finish here, make sure you click here, exit from the sketch. Then Control 7 to see this is our sketch. Then go to sketch again. Down here under sketch, click 3D sketch or select 3D sketch. Then take a line. I told you want to use 2D sketch and 3D sketch combine to create a simple table frame, and then we see the power of SolidWorks. The power of SolidWorks. How SolidWorks is very powerful. When you're using 3D sketch, you can click on the point you want. You take a line, you click on the point you want, and use tab command to change the orientation of the line. Okay, or the sketch. So click on this one. This. Hold on Control. I want to make them all equal. Hold on Control. Select this. Select this one. Select this. Select this one, and then release the Control button. Then pick this one as equal. Press F button. Take smart dimension. On this, you can put the height 700. This is a start table. Then you can put a support for a start table. Maybe click on this point, any point. Then ensure you tap. You tap, so it goes this direction. And pick another one this side, maybe from here. Let it go this way up to there. Then the last one, maybe from here, you can tap, yeah, like this, it comes here. So you can span dimension our part from this far end to this far end. You can put it like 254. 254 from here up to here, the same. You can put 254. So your sketch is fully defined. You see here it is now fully defined. Then what you do just exit. So you have combined a 2D sketch and 3D sketch. That is making a table. Then we need to go to Weldments. It's not here, that's structural. So what you do, place the pointer here, right click, then say tabs, go to sheet, that is a Weldments. We're using Weldments. When it comes here, you click on Weldments, or you click on Weldment again, then structural member. You can change here. We're using ISO. I like using ISO. The type I want to use rectangular tube. Size is 30 by 50 by 30. Group here. You can pick this one. Check the orientation. So this is the orientation. If you don't want that one, you can rotate. You click here, then change the angle, maybe 90 degree. You see, then click new group. Add this. If you don't want the angle, the way it appears, change here to 90 degree. Like that. New group. So that you create a cut list. Change this one, change orient it to 90 degree, like that. Then the last one, new group, pick on this, like that. You can also change to 90 degree, like that. Okay. Then you can pick the lower one. This welding table, so it should be strong. Can you click new group? That's why I put this support. Then this one I can also change the angle. I can put 90 degree, like this. So you see how it appears. Okay. Then you can put new group for the legs. You want it to appear like this? It's not good. Maybe I can change the angle 90 degree. That is good. If I want to see it, Control 5. I want to see at this corner. How does this corner appear? If you feel it doesn't appear the way you want, what you do, first of all, treat these corners. Click on this far corner, then you can use this arrow to trim the far corners. You can use this arrow, trim the far corners. We call it end treatment. Yes, use these corners to treat the corners. We have this. So click on new group, then pick on this handle. Before you change, Control 5. Check if you want it to be like this or you want to change. For example, if I want to put 90 degree here, I click this, it changes like this. So I want to fit it there. Can pick another one. Control 7, new group, pick this one. I want to see how it appears. Control 5, top plane. So this, I want to also change this one to 90 degree. It goes inside like that. Control 7, I want to change a new group, this and this. When we combine them, Control 5, I want to change this one to go inside the 90 degree, like that. Control 7. So I can put another new group, Control 1. So this one is okay. I need to rotate. New group, this, Control 1, this okay. New group, this one, Control 2, 3, it's okay. So you see this one is okay. Then once okay, click OK. I'm able to hide this sketch. These sketches, I can hide the sketches. And then now this is our table. You can check if it is well treated, each one of them, if it is well treated. For example, if I want to add other features here, I can come to my 2D sketch. So edit the sketch. I can add another sketch here. This sketch, I can add another sketch here, for example. Maybe let me put a simple sketch here. I'll show you. Then another sketch here. There's a reason why I want to show you this. This is a very good trick. So this is 254. Also this is 254. That is 10 inch. 254. Then exit. Okay. Once you exit, it doesn't come here. So unless you show it, click here, show. The sketch will come. And then I want to add something here. Then I show you how to trim. So what you do, click here. Start to remember. I want to use a square tube of 30 by 30. Yes. Then click on this. Then this one and this. Click OK. Then come here, hide this sketch. You see, this part, it's elongating inside because this material and this material are not the same. This is that square tube of 30 by 30. This is 50 by 30. If you look at this one, is protruding inside. So what do? You come to trim. Then I want to trim this one. but I want to use bodies. So click on bodies, then pick this body and pick this body. So I want to cut. This is the one I'm keeping. Yeah, I'm keeping. If you click this, it removes. But I want to keep this. So you click there, you keep. Click OK. You see, now it has cut the joints. You can also come this side, trim again. You can pick this what I want to trim, change to bodies here, pick this body, and you click OK. So this, it has created what we call a cut list. This is a cut list. I'm able to put at the top, at the end of it also, to prevent it being sharp cut in the floor, I can put what we call end cap. These are the end cap. Put end cap, click on this face, and end cap. Maybe if I put end cap, I can do symbol evaluation, measure this radius, and put it 2.6. So I can just come to Weldments, end cap, pick this region, then I say corner treatment, fillet of 2.6 to be inside. Then I can change this one to be inside or this. So either way, that suits you. So in case you want this one to flash out, okay. So let me use the flashing out. Then you can also change this, pick these ones, all of them, one by one, until I have the end caps. Yes, pick this and this. Okay. I can also apply material. Come here, edit material, apply material. I want to use alloy steel. Apply cross. Then you can save your table frame. Frame. We go to downloads. That is design. That's what you save there. To mix. Save there. Let me just save there. Okay. So this is our frame. So we have done a design. So in case you want to add wood on the other side, you can do that one. That's what I wanted to show you, how you can combine 2D sketch and 3D sketch and then you design. Also, this structural, if you look at this structural, what you have done, for example, you click on structural member. Here, for square tube, let's say for rectangular tube, we only have this size. But in case maybe you only 75 and maybe and 50, it's not there. What you do is you just come to this sketch, then click here, edit. You put your dimensions. This is the profile for rectangular. We call it RHS, rectangular hollow section. So you can change this 75. You can change this to be 50. Then you click exit. It will just update the dimension all across. So this is the part of design. From here, I can also do an analysis. For example, let's do a simulation. We'll see what do an analysis. We want to see how will this one behave in case I'm going to put a load of maybe 10 Newton or 20 Newton. How will it behave? Let me check the simplest way I can do an analysis for pressure or for force. But if I assume I'm using not a beam, so I can assume that I'm not using a beam, so I can do a simple analysis to see how far or how much it will behave when it is loaded. So that is what I'm going to test again after finishing our simple structural design. That is the beauty of SolidWorks. Okay, so let's go to simulation again now. Let's go to simulation. I think still loading simulation because I've just activated simulation. So let's go to simulation, then click here, new study. You can use an advisor. I just want to say table analysis. This stress analysis. In this analysis, you have 2D. I can use 2D static. You can use thermal analysis, backwarding analysis, fatigue, linear, linear dynamic, submodeling, whatever. But I want to use static analysis. Then click OK. From there, we know you have applied the material. You have applied the material. So the first thing is you need to apply a material, but already you have applied the material, so you can go to fixtures. I want to support the lower side. It doesn't move. So this is the place I want to support. This is the place I want to support. This is the place I want to support, and this is the place I want to support. Okay, then I click OK. So the table will be standing on the ground, so the support is on the lower side. Then I can come to load. I can use force, so I don't pick the beam, or I can use pressure. Let me check pressure. Normal face, I can use top plane. Reference geometry, let me use the top plane. Reference geometry, top plane. Then I want along which direction, maybe direction 2. You see, if the direction 2 is going this way, so let me check direction 1. Direction 1, direction normal to plane. Normal the plane would be like this. So direction 1, like this, is not good for this part. Select faces. I want to take these faces. These faces. I want to ensure that their forces align on this. Pressure is being exerted on these faces. Yes, like that. Just let me just use 2. In case I wanted to change direction, I can also reverse here. Then I want to mark a factor of 300. You can see the force. Yeah, 300. It's too big. 200. Okay, 200. 200 is okay. Okay. You see, that's why I didn't want to use the pressure, because it will require me to use the beam. But I want to do very fast. So what I want to do is I will have to change this one to the beam, and yes, I've used that pressure. You see, pressure requires you to convert to a beam. I just wanted to use this. So let me put the load as force so that I don't take too much time for this preview. I just want to see how it will behave. So let me use the pressure on these faces, not the force. I just want to use, in the case I'm putting a 20 kg bag on this frame, how will it behave? Or in case I'm putting heavy machines on this table, how will it behave? I'm using weight. That's Newton. Don't make, say, somebody has put 100 Newton on the frame. What will happen? Okay. I can also expand the symbol. It's normal. You can make a symbol here to be 200. You can see the pressure, the force. Yeah, 200. I can able to see it. Okay. Then I can put OK. Let apply on the edges. Why? Can I apply? Let me apply on the joints. Then that's the case. Let me apply on the joints. If this is the case, I can apply on the joints now. That will pick the joints to pick it as a beam. So I'm applying on this beam now. It's okay. And then I want to use force. Let's say force of 50. 50 is okay. Then I want to use this force. And then selection is top plane. You see this force, it is going wrong side. So what you do is we change this, you pick the other one, you preview like this. So you pick the last one, preview like this. So you need the last one, that is 50 force, so it should be this last one. So when you preview like this, okay. Yeah, it is going down up. I want it to point down, so you can reverse here. It point down like this, you see. Okay. Then you can check that here we're using a reference plane as top plane. Then I've put a factor of 200 to magnify my force. Can now pick OK. That one. Then from here, I don't have any connections. What you do is I can create a mesh. The finer you put the faster the accurate the result becomes. So let me mesh. First of all, okay, create a mesh. After meshing, it take time. That's the problem with meshing, because I've put it so fine. That's why it may take a lot of time to do meshing across regions. And also remember, I've not done welding, so in case I do welding, I also ensure that the accuracy of the results increases. But let me do it first, and then I'll check, I'll add welding, then I'll see if that contact area will affect my result. Okay, then I can go to run now. Come here, run this study, click run this study. Okay, we'll be using all CPU. Okay, so let's use all CPU to run this study. So we're using what we call the table analysis of stress. Yeah, it has finished. So this is the behavior. The material has a yield strength of 6.204, but that is times x times x, that is times 10 raised power 0.8. That is what we have for the material. So if you look at this chart, it tells you that every time it is changing almost to red, areas that are changing to red, it may be close appearing to the approaching the yield strength, which is very dangerous. So those areas are the one you focus to reduce the stress or the yield strength. Okay, we can also check on displacement. For example, show displacement. This is how it behaves. You see, that's why I was to put this one to see how it will behave. So here it is stronger as compared at the center. So this one will help me to understand where should I put more support. If I say let me do animate this, I'm able to see the effect of loading, which will be more at the center than at the far end. So what I will do is this center, which means I need to put a support at the center in case I want to confine my design to use the 50 Newton weight. But in case I don't want to confine my design to use 50 Newton weight, I will now change the tube maybe to 75 by 50, because I've used 50 by 30. Then at this point where you are seeing becoming reddish is where the weak point is. It will fail. Even you can see this chart. I can click on this chart, right click, say edit definitions. I want to use the floating type. You can check here the floating type, charts options. Let's use the floating type, scientific. Let's use floating type. Okay, you see this deflection, it is 0.0, normally 0.0019 is recommended, but not 0.38 or 48. So this region is very weak. So this is now a guide. That's why you require what you call design analysis. It guides you to understand where is the weak point. So these areas are the areas and you need to focus. You see the legs are strong. They have support. So this region, we need to support this region. That's why I put this one to show you the impact of you supporting this. So in case you are putting that load, it may affect. Or I will come to my design model. I'll do like welding. I'll do like welding. For example, if I have, let me check welds. Weld. You can do weld. That is, let me see weld. You can search weld bit. You can bring it here. Then click weld bit. You can go to part geometry or weld geometry, part geometry. So I can pick this face. Yes, give a gap, maybe this face and this face, or you can use this one. You can pick this face, click here, pick this face. Then you see this is the weld. So you can define your weld if you're coming from which point to which point. You can change you put the symbol for the weld. You're welding both direction or selection. Also doing intermediate weld or normal weld. So see, these are part of the things you can do. For example, if I click on this, then I come to my table analysis. I can also do an analysis again. In case I do any change, for example, in case I need to do any change here, let me assume I have done this. For example, sketch something on top. I want to show you what will be happening on my design. I want to put this, maybe, for example, I can measure this one. This is this one is, let me go to evaluate, measure, and measure this. This is 1200. So I can come here, sketch 1, 2, 3, 4. So I can say from this point up to this point, we have 1200 divided by 4. From this point up to this point is my dimension again. Up to this point equals to this one. Yes, I pick this one to use equations. This 1200 divided by 4. Okay, then this one, and this one are equal. They are equal. This is the diameter. Let's say diameter 8. Control 8. And put a center line here. Put a center line at the center. This. Can click here. Mirror. Copy this. Mirror about. Click this. Okay. Then come to Weldments. I want to use Weldments. I want to extrude cut. That is 40. 101. It's okay. Okay. Then this is now recalculating the joints. You see, it is telling you to calculate the points, the joints. You can save or click here, rebuild, then go to your table analysis. You see, it is recalculating the joints. Then it is putting the question mark here. Why? Because I've made a change. So what do I do? Click on this one, right click, and then say run this study or update. Can click on update or run this study. So you can update, create a new mesh, then it updates. That's how you do a design before you make the product. But there are changes I've not made. So while I was doing my design, I realized there's some changes here, so I didn't finish those designs. Okay, so almost finishing. It's taking time, but it's almost finishing. Don't worry, because I've put fine here so that it can give me the result I want. Okay, so this is what you have obtained. So if I show this displacement, I want to see this color. So see this color now, so almost changing. But what do I do? So this is the area I will go in my design. I'll come in here in my design. I put a support at this center. So which means I can say now this one, edit the sketch. Edit the sketch. For example, can add this at the center, maybe this point. From here to here. I want to edit the sketch. Then put this somewhere here. Put this one somewhere here. Can put my dimension, maybe from here to here, can be 400, for example. This one up to here, it can be 1 foot, for example, or even 350. The reason why I want to do that one, let me show you why I'm doing that. How will it affect my analysis? So I want to show you the effect of this. So smart dimension. So you can take these ones, It would be just 165. We'll change them, don't worry. So put this one maybe 230. Then you can exit, Control 7, and then it is recalculating the joints, remember, because we are doing analysis. Then I'll come here on this second one. First of all, ensure that I show the sketch here, show the sketch. Come on the second square tube, I want to add square tube, edit square tube. Then I can add joints, so I can pick the new group, this one, this, and this. Say okay. Then let it recalculate joints. It will give me an error because I'm adding something. So I want to see the impact of it. Okay. Then still I'm under weldment, so I'll come to trim. If I trim, let me hide this sketch because showing me many things. I can come to trim and pick this one. This one I've added this. And to the body is this and this. Say okay. Trim again. Still recalculating. Okay. No problem. This is calculate. So I want to trim this and this because they are inner. Trim again. This one and this. What is to trim is this and this. Okay. The points this and this. So I have 1, 2. So I'll add other joints. So I'll come to my table analysis again because I've updated. There are points that I had put for the force. So I'll come here on the force, click here, edit, load. So I'll have to add this point, the new points. So this point, you have this point again. I've added this one. So I'm adding the points I've added. Those points. See? Those are the points I've added. So how many are they? It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So what you do, you can click here, say clear. Then you pick again, you can pick this, you can pick this one by one, like that. So because we want to update, pick all this, pick all this, this one, you're picking all this, these joints, computer is taking time to think. You want to add all these points, then we see the impact. Okay. So I've added all of them, click OK. And then I'll come here, say update all components. Update all components. So it is update all components because I've made some changes. Then I can come here, say now run study. So it have to now recreate the mesh to update any changes. Then from there it will now run. We want to see what the changes we have made. Does it have any impact on our design? So this is what we call stress static analysis. So we'll be using von Mises to do the stress analysis. Those are terminologies that designers are able to understand when they're doing their analysis. So they see what will happen. It has finished doing the meshing. So this is also now updating the stress analysis. for the part. So this one will guide me. I will know where the area weak points are. Can come here using von Mises. You see this is source von Mises. Can come here. Then say, then we go to displacement. Show displacement. You can see these are the more areas. You see now the weak point now have now shifted to this region. So what I can do, maybe also I can say, normally when you're designing it's just a guide. Why is it bedding? Is that there's no support going downward here. So support going downward there is a problem. So also you can change either the force applied, or you can change the material thickness. So let me assume for this that is just basic tutorial. In case you want to understand more, you can search stress analysis from SolidWorks online on YouTube. You'll be able to find how it is done. There are so many people who have done it, but you need to understand first of all what is stress analysis before you even try to do analysis using the softwares. You can also use ANSYS to do simulations, because it's the powerful software for simulations, able to show you how to do analysis, how you can analyze your design before you make it in the interaction. Okay, you see it has changed. The reason why here it is bending too much is because there's no support going down. At the far end here, there's a support going down. The support going down, but here there's no support going down. But I can do what you call in this results. I can come to this edit the results, stress analysis. Then I say, give me a true value. I'm using a true scale. Then okay. Also for stress analysis, displacement, edit definitions, can say I'm using a true scale. So it can update the values to show that whatever is obtaining is a true value. Can also edit here that I'm using a true value or true scale. So I put true scale. Okay. So in case I want to show displacement here, I can show maybe stress and strain. Then I can come to strain. I can say animate. See, now according to the true scale, now it is this. If I go to displacement the same, show, then animate. Yes, you see how it is behaving, how the forces, how the displacement will be distributed. Now I've assumed this a true scale. That is how we're able to do stress analysis using void mixes. So our main objective was to create a well-made frame using SolidWorks. Then using 2D sketch, 3D sketch, from there we're able to do intermediate weld using these parameters. As you see, they are here, all of them are here. From there we're able to do stress analysis using static analysis. From there, stress analysis, we have shown how each of these stress, displacement, and strain are related if we are using von Mises with the standard mesh. Okay, so this is what we have covered. So in case you want to learn more on this, you can book for classes which show you how to get engaged on how to use this what called Weldment or Weldment tools. As I said, also you can do welding in SolidWorks. So this is just for purpose of introducing a welding. So next session we'll be doing detailed design of structural components, then doing analysis like water tank, tower. How can we ensure that the water tower is strong, doesn't have any failure points? Okay.